This is a quick video over P-only control and bias. Actually, what this video is mainly about is bias and what bias is. So right here we have a tank, and what we want to do is control the level of the tank. We're going to control the level of the tank by the flow out of the tank right here, and how we're going to control the flow out of the tank is by controlling the percent the valve is open. Now, the PID control equation is right here, and this equation controls the percent the valve is open. So what we have is CT is the percent open the valve is, C hat is the bias, which we'll be focusing on, KC, which is the controller gain, and ET, which is the error at time t, and we're not going to really look at the integral or the derivative control. So really we're looking at this part of the control equation. So what is bias? Well, let's say we want our tank to be 50% empty. So if we start the program, clear all the graphs, turn on everything, and start the program. So originally we have our bias set at 1, right there. So what that means is the valve is 1% open, or it's 1% open plus KC, which is the controller gain, which we have set at 9, times the error. So initially the tank was at 50% empty, so there wasn't any error. However, the valve isn't open enough to allow enough flow through the line, so it's actually filling up. So we actually get this error generated. Now as the error is generated, we increase the percent the valve is open. So now the valve is open around 2%. But however, we're getting error. It's opening up, but it's nowhere near the 50% we want. So let's just fast forward it real quick. And what we'll see is that it will actually come to equilibrium, or kind of not our steady state, not equilibrium, where we have this constant error. We have constant error, and that's just due to the error is needed to open the valve more than it is normally. Normally it is at 1% open. Now we can change that. We'll change that, so we'll start all over, and let's change the bias to 3. So we'll start the program, turn on everything. So now the valve is 3% open, and it's allowing about 1.8% or 1.8 liters per second out. So we have about 2 liters coming in, or we have 2 liters coming in, and 1.8 liters leaving. So there isn't too much error being generated right away, but as we generate that error, it's being multiplied by 9, the controller gain, and added to our original bias, which is 3. So 3 is actually a pretty good bias. So our valve is around 3% open. It's actually going up a little bit. It's at 3.1% open. The total percent open the valve is. So let's actually fast forward a little bit. So we see we don't actually get dead on our error. We can actually decrease this error by increasing the controller gain. So we can maybe make that equal 20. So now we're multiplying the error by 20, so the valve is going to open up a little bit more for every bit of error. But however, remember, for P-only control, you need error to make adjustments. So now bias at 3 seems like a really good thing. However, that's only when we have the tank at 50% empty and we have 2 liters per second of fluid flowing in. If we were to change this to 3 liters of fluid flowing in, so 2 liters of A and 1 liter of B, our bias is no longer any good. So see, now we get that offset again. So now you need a bias for each type of scenario. So let's look at another one. Let's see what do we need to get that. So we'll clear all that. We'll start the program. Actually, we'll stop the program, clear everything, turn on everything. There we go. So now we have 3 liters of fluid flowing in, and we want it to be at 50% empty. Right off the bat, we have too much fluid flowing in, so it's filling up, and we want it at 50% empty. So we're getting this error generated, and as we generate that error, it's opening up. Even though our bias is 3, we have about 4% the valve being open, and that's causing about 2.6 liters of fluid to flow out. Still need to get it to 3, and most likely we won't get there because, again, we need that error to open up the valve more. So right now we have, how much error do we have? it looks like we have about 8% error. So again, if we want to decrease the amount of error, what we can do is we can increase the controller gain. Maybe we'll do 40 this time. So what we see is we see the controller gain portion of the percent the valve is open jumps up significantly. The valve is now 5.2% open, and we have 3.3 liters of fluid flowing out. So it's emptying, which is a good thing. So let's go a little forward. But you see, we still don't reach our set point. So let's say it's 80%, 80 open, which is ridiculous. But we'll say it's 80. The controller gain is 80. So now the error being generated is multiplied by 80. So now we're getting even closer. So we'll fast forward some more. We're getting very, very close. So maybe this is actually a really good scenario where we have the bias at 3 and the controller gain at 80. So let's start the program over and see what happens. Clear, start program, turn on all the valves and pumps, and we will fast forward. So that seems like a good thing. Let's do a step change. Let's say we want it to be 0.4. So now we want it to be 40% empty. 40% empty. And we're close to that. And we're actually almost dead on to that. So we'll fast forward. We have our step change, which is right here. At 2,000 seconds, it's changed to 0.5. So that seems to actually work pretty decently. Now the problem is, if we wanted to add integral action, we would get something crazy. So that's why you can't have these massive controller gains, because you get really bad integral action when you turn on integral action. And what integral action is actually takes the place of bias. So if we were actually to stop the program, clear everything, let's put back K to maybe 20, something reasonable. So stop the program, we will clear everything, clear, and we're going to have integral action on, and all integral action is the error, summation of all the error. That's all that is. So if we actually have the bias at 0 and we start all over again, we'll turn it on, turn on everything. So initially everything's shut. We have this massive takeoff. The P only controller is taking off right away. So we got that going up there. Let's fast forward just a little bit. So remember, originally we had the controller open. We had the bias somewhere around here. Somewhere around here, 3. Well, now what you see is the integral action is actually taking the place of the bias. It's staying steady up there. P only control is having no effect because there's no error being generated. The error is 0 at the moment. So that's the benefit of integral actions, because it will take the place of the bias. And often what you'll see is if you have a PID software, sometimes it won't even let you set the bias. Sometimes it just automatically sets the bias to 0, or whatever the valve was, whatever percent the valve was open when you turned on the PID software. So that's the general idea of bias, is that it's the percent of the valve is open. Turn off integral and just go look at it one more time. It's the percent the valve is open when there is no error. When your system is at its set point, that's how much you want your valve open. So that's the general idea. Or closed. You can have it be a negative number, I guess. I don't see why you couldn't. Not a good idea, but I mean, you could if you wanted to. But I mean, that's the general idea of bias. Is how much do you want your valve to be open when you have no error? No error. So if you want to mess around with this software, you can actually go into the description below. There's a link there. I do forewarn you, I am not a professional programmer, so please take that into consideration when you decide to use this software.